Hello, in this video, I'm going to start with a short question. So combining what we have learned earlier, I will ask you, what is this probability? Probability F cap H complement. By the way, here, complement is attached only to H, right? So do the complement first and then take the cap. So stop the video if you need time and try to find out which outcome is included in that set, in that event. Okay, so the answer is first. Let's study each of the event. F is here. We know female includes these two types, and H includes these two types. But what we are interested in is H complement. So flip the color. So H complement is these two types. And then we take cap intersection. So that means intersect between F and H complement, which is only this type. The answer is A, right? So, by the way, what I show you here is this is just single outcome, right? But its expression can be quite complicated because the basic events F and H are defined only for each variable. So F includes actually multiple outcomes, and H includes multiple outcomes. But after, like, it takes a few manipulations to isolate one outcome. So this is the difference between notation and underlying principle and the actual information we have. In practice, we usually see probability of female, probability of health insurance, but we don't think about the underlying four types. So, but when the problem becomes more complicated, it is more important to connect them because you can be confused otherwise. So you have to understand what you are doing, and a lot of like statistical tricks, like misleading statements, are based on this difference. It does not clarify what's included and what's not. Okay. Okay. Here, the next one. We learned three operations, and what I'm going to give you here is a general rule that connects the probability between union and intersection and the simple basic probabilities. So remember, F cup H is the union, which is the biggest set. So it contains F and H, like either F and H, right? So we'd like to express this using the basic probabilities. So we know the basic probabilities, but we are interested in the union. Then how can you do that? The answer is like this. So remember, the union, when you calculate the probability of union, you are going to sum all the probabilities of the outcomes included in this union, right? So basically, it's a summation of outcomes. And you sum two basic probabilities. But when you add these two probabilities, there is one outcome that is double counted because there are overlaps. The overlapping area is the intersection. So the intersection is included in both F and H, so it is counted here and here. So double counted. You have to subtract that part to obtain the correct probability. Okay, so literally there is an overlap, so you have to adjust that much. That is the relationship between union, intersection, and the basic events. Okay, this is general rule. It holds always. And there is a special rule. So many textbooks only show you this formula, but this is not general because it requires an assumption. So given the general rule, so this part is the main kind of problem. I don't like this area, this part because the formula is not clean. Add something and subtract something. Oh, it's not clean. So then, if you can assume that the overlap is 0, there is no overlap, then you can simplify the formula to a more beautiful one, more pretty and clean formula. So that is called special addition rule, I say. But many textbooks only use this as a formula. But it's less valuable mathematically because it requires condition. It's more restrictive to utilize this formula. Idea is simple. So when you say the intersection probability is 0, that means they don't happen together. So remember, the intersection happens when two events happen together, but its probability is 0. Say that means they don't happen together, so there is no double count, right? And then in this case, this special condition is said mutually exclusive. So F and H are mutually exclusive. That means when F happens, H does not happen. We know that because we know they don't happen at the same time. So when you see F, then we can exclude H. The possibility of H can be easily excluded. Vice versa. So in that sense, we say both events are mutually exclusive, and in that case, you can use the special rule, like simple rule like this. But in our example, but this is pretty rare. Mutually exclusive cases, if you have this assumption, it's nice, but not that common. Like for example, our example is not mutually exclusive because, like for example, F and H, like go back to here. You know, the intersection is not 0. Probability of the intersection is 36%. So even if F happens, even if you know that F already happened, still H may happen or may not. So they are not exclusive. So be careful. It's pretty confusing. But one thing more clear is the general addition rule. This is a more important rule you have to remember. Okay, the next part is about joint and marginal distribution. So when I explain up to this point, actually I gave you the idea of joint distribution and marginal distribution. So when you have multiple variables, you can think about probability for multiple variables jointly. That is joint probability. For example, probability of female having a health insurance. So intersection union require two information from both variables, so they are joint probabilities. But marginal probability is about a single variable, like probability of female, probability of having a health insurance. It does not require two variables at the same time. You just need only one variable, and you can delete the other variable. Still, you can calculate the probability. So then we call this marginal. And what we have done so far is consider to make a joint probability distribution table like this, right? So this is the joint probabilities of like for 4 outcomes. But suppose that we are not interested in gender. We are interested only in health insurance, right? So you don't need another variable. Then how can we transform this 2x2 variables into only 2 probabilities for health insurance? The idea is simple. Just so if you are interested only in health insurance, you need only 2 variables, 2 probabilities. The probability of not having health insurance and the probability of having health insurance. Each of them can be calculated by adding these 2 variables, these 2 probabilities. So probability of not having a healthy insurance is 13.8 plus 19.89. So it's sum of these two numbers. And the probability of having a healthy insurance equals this probability plus this probability, which is 66%. So then, as a result, the marginal distribution for healthy insurance is the summation. So, like, how do I say? Summation all across columns. Row by row summations will give you the marginal distribution for this variable. Similarly, you can do the marginal distribution for gender. So probability of female is sum of these two numbers, 50%. Probability of male is sum of these two numbers, 49%. So probabilities are calculated. So marginal probabilities are calculated this way. So what I'm showing you here is pretty simple. When you have the joint probability distribution, that's all the information you have. That contains all information. And from if you have complete information, it is easy to delete some information. That is always easy, right? So just ignore some of the information or manipulate that to limit the focus on one variable. That is always possible. But our next question is the other way. Suppose that we have marginal distributions for gender and healthy insurance at the same time. We have these informations. Then, can we recover the joint probability distribution? In other words, these two marginal distributions contain complete information or not? That is a different question, right? The answer is no. The answer is no. So, for example, let me ask you this way. So we know that how many people, 33% don't have health insurance and 50% are female. Based on these numbers, can you calculate the probability of female without health insurance? Try this, guess it. Okay, the answer is no, because it's not fixed. So let's put it this way. Think about this. This was our true joint distribution from the data. So this was our original data. But I can manipulate the number and make up the same marginal distribution. So assume that there is 0% female without health insurance. So I fix this number as 0. Still, you can fill the other entries with appropriate numbers to have the same marginals. Get it? So even if you change one of the numbers, and if you match the numbers in the other entries, then you are going to get the same marginal distribution. So from this joint distribution and from this joint distribution, they produce the same marginal distributions. That means by looking at the marginal distributions, you don't know whether these marginal distributions are coming from here or here. It could be the top or from the bottom. Both joint distributions are reasonable, rationalized by the marginal distributions. So that means marginal distributions are not complete information, which is pretty important. Or, okay, let's put it as an algebra. So from the same question like this, based on these informations, we would like to do something. Calculate the probability of female without health insurance. How can we do this? We need to do this. We will put x, y, z, w unknowns for the full joint distribution. So we start from the joint distribution as if we know that, but actually with unknowns. And then from here, if you calculate probability of not having a healthy insurance from the full distribution, you are going to add x plus y. So the information we have can be written as x plus y equals 33.69%. And we know that the probability of female is 50.52%. So that is x plus z equals 50.52%. So these are the informations we have. So we have two equations for four unknowns. That means you cannot solve for these unknowns. So you cannot solve them because there are not enough number of equations. Then how about this? Now I'm going to give you another one. So the first two informations are the same, but I'll give you an additional one. 19.89% are male without health insurance. Seemingly unrelated information, but does it help? Would it help or not? If you are mathematically smart, maybe you can try the algebra as I did before and see if you can handle that. Okay, I'm going to give you the answer. The answer is yes. Yes, like, so if you choose no because there are only three equations for four unknowns, that makes sense. That makes perfect sense algebraically. But what is hidden is, so this is what you have. If this was what you have in mind, it's great. You are good. But actually, it was my trick. There is hidden information, like because it is probability. They have to satisfy this condition always. Sum of all probabilities must be on 100% always. So this property of probability serves as the last equation. So you have the answer. You can solve for the unknowns. Four equations for four unknowns, and then simple. Let's simple solution for linear equations. So if you compare equation 1 and 3, then you can isolate x, right? And when you know x, then you can isolate z from number 2. And when you know x, z, and y, then you can recover w from here, right? So I believe you can do this. Then this is a very interesting result. Like you need just one more information to recover joint distribution. In other words, marginal distributions are not enough. That is the most important point. But if you have any other information, then you will be fine. Okay. By the way, you may ask this question. So we have, like say, for example, here information is 50.52% are female. Then you may ask a question like, we know the probability of male is 49%. Why don't we use this? That information is actually useless because if you know female is 50.52%, this information is automatically implied by the same property of the probability. So adding this information does not help us. Similarly, if you add 66% as another information, that is basically the same information like as this. So in that sense, what you need is another information that is related to both variables, male and health insurance. It should be not just male or having health insurance, but like either male having health insurance, male without health insurance, or vice versa like that. So then you can recover the joint probability, and that is what we need to recover the full full information. So we know here, and this is basically to recover the, so XYZW solving for these unknowns is to recover the joint distribution, the full information. Once you have the full information, you can do whatever you want. You can calculate any probability. So that is the best way to handle the problem. And we may connect this also to the general rule of addition. So you want to calculate the probability of union. If you have marginal distributions, you cannot recover them. You need additional information. That can be intersection, or the information that intersection equals to 0, right? So, like, as you see, you need two marginal distributions and something that is related to both of the variables. That is another approach to understand the general addition rule. Okay, this is the end of chapter 1. Of course, chapter 1 is pretty easy, and it will get more difficult as the semester goes. And I'm going to, I guess you can find quiz number 1 on Brightspace, and I'm going to upload a guide video for that quiz. So you may think it's too easy. Yes, it's easy, and my goal is to give you the maximum possible points if you are willing to put your efforts. So if you are willing to get the maximum possible score, I believe you can. Like, it's a matter of your effort. You can watch the video again, you can watch the guide video again, you can try the quiz again up to 10 times. So I'm telling you, you may think it is too easy to collect points, but at the end of the semester, I see a lot of students who missed the opportunities. At the time, I cannot break my words. I have to give the grade according to your points. And another thing I wanted to say is, it is online teaching. So there are a lot of good things about online teaching. I like teaching online. It's flexible, and you can choose your pace. Like, for example, if you knew how to use pivot table on Excel, you can skip that part. But but to some students, that part would be the most useful part in this lecture. So you may repeat that if you repeat a certain part. If you could not understand it well, you may watch videos from the last year if you wanted to listen to another lecture on the same topic. So it is up to you. Instead, there are a lot of advantages of teaching online, learning online, but the problem is many of you tend to delay, procrastinate. I understand. So I will be very harsh, very strict about late submission. I gave you 1 week grace period. As I said in the introduction video, I'm not asking for any documents. I'm not asking for your excuses, explanations. It doesn't matter. Just be on time. I gave you one week grace period without any proof of your emergency. So that's up to you. If you are later than if you submit your quiz later than the grace period, then there is nothing you can do. There is no partial credit. There is no extra credit. There is no makeup. So, as I said, it is very strict. I have to be strict to handle. So I have more than 110 students in 2 sections. So I have to be strict. Otherwise, everyone is going to come to me and beg for extra credits. And my answer is always no. So believe me, I will be very strict. And it is up to you how much effort you put in here. I'd be happy to help you if you need further help. So feel free to shoot me an email, and if you have more questions, please yeah, help me. Please shoot me an email. Okay. So okay, it was nice to record the lecture, and I will keep doing this for 12 chapters. So there will be lecture videos every week. So hope you follow them without delay. See you later. Bye.